Okay. So today's task is to go over these things. We're going to start with our definitions of temperature, heat, and work. We are going to talk about defining work. We are going to talk about heat transfer and stuff. Okay, so as a step one, let's start this discussion by talking about a few definitions. So the first thing I want to define is what is temperature? What is temperature? It's how I feel about it, my environment. Is it hot? Is it cold? Is it normal? What is it, right? That's the definition of temperature. But in thermodynamics, for temperature is the measure of any object ability to spontaneously give up energy. Remember that energy word that we were talking about? But temperature is the ability of an object to give up energy. Okay. You can also think of it as an inherent property. What's an inherent property? What eye color do you have? That's your inherent property. Can you change your eye color? You could wear contacts. But yes, you really can't change it. Inherent properties are those properties that are inherently the objects. For example, your hair color. How many people have brown hair? How many people have blonde hair? How many people have, auburn? Caitlin.
Red, auburn, whatever, yeah.
Yeah, right, auburn, red. Can you change it? Yes, sure, you could dye it, but what happens after a little while? It goes back, right? And so that's an inherent property that you have. I want you to know that I have not defined temperature. I have given you a statement about temperature. That is true for thermodynamics. So everything that I have told you is just a statement that holds true for thermodynamics. Okay, then what is heat? Heat is the spontaneous, important word, flow of energy from the object at higher temperature, which I will call TH, to an object at lower temperature, which I will call T subscript C. If I put a heater in the corner of this room and the room is really, really cold, what will happen? What will those hotter molecules do? Will you have to do anything in order to spread them? They will do that spontaneously. If you put cold milk into hot coffee, what will that do? What? Diffuse. Do you have to do anything? They will diffuse automatically, right? How can you help it along? But if you didn't agitate it, what will it do anyway? Right? It will still reach thermal equilibrium. So that, by definition, is heat. Then what is work? Work is transfer of energy that is not spontaneous. So when we say that it's not spontaneous, what must it have? It must have an external force that is causing this to happen. So we define that external force or whatever's causing this as an agent. And the job of the agent is to put energy where it does not spontaneously want to go. Does that make sense? So what's the job of an air conditioner? Cool the area that it's made in, right? And how does it do that? So it is actually, so spontaneously, hot air will flow into the colder room. But if you wanted to take the heat away from a colder air environment, what would you have to do? Provide an external agent like an air conditioner or a refrigerator, right? To take where heat doesn't want to go in order to change the temperature. Does that make sense? Okay, good. Okay, now, what's the difference between heat and work? I want you to do something. I want you to hold your hands together. I want you to rub them. What's happening? They're getting warmer. Why are they getting warmer? Yes. Well, true. But in terms of thermodynamics, they are getting hotter, right? But according to thermodynamics, you are not adding heat to your hands. What are you doing? You're doing work on them. Okay. Microwaves. How do microwaves heat your food? Well, true. But how do they do it actually? Anyone know?
They take
Yes?
the microwave, the length of the microwave ray is perfectly sized to vibrate water molecules, which causes the food to heat if there's water in it.
That's exactly right. So what the microwaves do is that they are built in order to agitate water molecules that are present in your food. So if you've ever heated up frozen food, that is why when you put Maggi noodles or, ramen noodles into your microwave, what do they always tell you to do? And what if you don't add water? Well, that's true. And then the fire, wait, who was there when that happened, where there was a kid who put ramen noodles into the microwave and then the firemen came because it was your class?
Yeah, it was everyone.
Yeah, and then the fireman came, and then the story goes that they said, why did you not put water in it? And he said, but I wasn't thirsty. So microwaves don't heat food by adding heat to them. They heat food by doing work on it. Does that make sense? How do we then say the difference between heat and work? Very simply, heat is spontaneous energy transfer And work is non-spontaneous energy transfer. So for heat, do you need an external agent? But for work, you do.